Hello friends and dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 9 video on the topic of determination of density of solids, where I will solve 5 multiple choice questions. So this is set 2 of solving numerical problems on the topic of determination of density of solids from the chapter of Physical Quantities and Measurements. The key concepts and formulas based on which the key concepts and formulas of determination of density of solids was discussed in part 7 of this part 7 video. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 9 video, where I will solve 5 multiple choice questions on the topic of determination of solids, determination of density of solids. Okay, so the first question says that when n number of small pebbles is added to a measuring cylinder, the reading changes from xml to yml. If the relative density of a pebble is q, then mass of each pebble in kilogram is. Okay, so we know that when n number of small pebbles, of course, all the pebbles are identical. That is, they will have same mass and volume. So when the n number of pebbles was dropped in a measuring cylinder, it says that the reading changes from xml to yml. So definitely the volume of all n number of pebbles, if that is capital V, this will be equal to the change in reading of the measuring cylinder, which will be, or the increase in reading of the measuring cylinder, which will be y minus x, this much ml, which is ml is 1 ml is equal to 1 centimeter cube. So I can say y minus x centimeter cube is the volume of all the n pebbles. Okay, so volume of each pebble will be equal to, since all the pebbles are identical, so volume of each pebble, individual pebble, will be V by 10. Since there are, sorry, V not V by 10, but V by capital N will be the volume of each pebble, which will be equal to y minus x divided by n, this much centimeter cube. This is the volume of each pebble. Now the relative density of the pebble is given as q. So I can say that the density of each pebble will be equal to q. Since the relative density is given as q, the density of each pebble will be q gram per centimeter cube. Okay, so we know the volume of each pebble, which is y minus x divided by capital N centimeter cube, and the density of pebble is capital Q gram per centimeter cube. So this implies that mass of each pebble will be equal to volume multiplied by the density. So it will be so basically it will be V by N multiplied by the rho, not rho but Q, since the density is capital Q gram per centimeter cube. So Q, this much gram. Now V by N is y minus x divided by N. So this multiplied by Q gram. So this is the mass of each pebble. Now the question has asked to find the mass of each pebble in kilogram. So definitely this will be Q multiplied by y minus x divided by m and whole multiplied by 10 to the power minus 3, this much kilogram. Okay, So the correct answer, the correct choice is choice B. B is the correct choice. Okay, let's see. Now, if you find difficulty in following my in understanding my explanation by solving the problems, or or how I'm applying the concept, then please feel free to let me know in the comment section. I will do my best to address your query. Let's see the next question. A metallic cylinder has a length twice its radius and a density of rho gram per centimeter cube. Find the radius in centimeter of the cylinder if its weight is mgf. Now GF stands for, GF is a unit of gravity. GF is a gravitational unit of force or weight, which means a body having weight of capital M, GF means that the body has a mass of capital M. Okay, so the question has asked to find the radius. Okay, first of all, the mass. Now the weight is already given as capital M GF. So the mass is m gram. Mass of the cylinder is m gram. Okay. The density of the metallic cylinder is given to be rho gram per centimeter cube. Okay. So to find the radius means that first of all we need to find the volume of the metallic cylinder. Now we know the mass, we know the density, definitely we will know the volume of the metallic cylinder. V will be m by rho, this much, m by rho, this much centimeter cube will be the volume of the metallic cylinder. Okay. Now let's say the radius. So a metallic cylinder means a cylinder is this. So let's say the radius is r centimeter. It is given that a metallic cylinder has a length twice its radius. So if you consider the radius to be r centimeter, the length or the height will be twice r centimeter. Now for a cylinder having a radius r centimeter and height or length 2 r centimeter, we know the volume of this is a right circular cylinder, the right cylinder. Its volume will be pi r square h. That is pi r square. R is the radius, so this will be pi r square h. H is the height of the cylinder. Since it is given that the height or the length is twice the radius, so height will be 2r. So this is the volume of the cylinder. This is which is equal to 2 pi r cube. So we can now equate volume from the mass and density we have found to be m by p, and also by considering the radius to be r, we have found the volume to be 2 pi r cube. So m by rho should be equal to 2 pi r cube. From here we can easily find the r. So r cube is equal to m by 2 pi rho. This implies r will be equal to m by cube root of m by 2 pi rho, which in the exponential form is m by 2 pi rho, this whole raised to the power 1 by 3. So m by 2 pi rho whole raised to the power 1 by 3 should be this much centimeter, should be the radius of the metallic cylinder. Now let's see. The choice A is the correct choice, but it is expressed in a different way. As you can see, choice A, the power is minus 1 by 3. So if you convert the power minus 1 by 3 to 1 to power 1 by 3, you just need to you just need to reverse the numerator and the denominator of the base. So it will be m by 2 pi rho. So definitely the correct choice is choice A. A is the correct choice. Okay, let's see the next problem. Question number 3. A metallic stone of density rho kilogram per meter cube and weighing W kgf when immersed completely in a measuring cylinder increases the reading by capital P ml. Then the value of P is, okay, we have to find P. So what is given? A metallic stone, okay. The weight of the metallic stone is W kgf. This implies weight is given to be W kgf. Kgf means kilogram force. Kgf is a gravitational unit of weight or force, which means it is the gravitational force that acts on a body of mass W kilogram. So this implies the mass of the metallic stone is W kilogram. Okay. The density is given as rho kilogram per meter cube. It is given in SI unit. Clearly, we can say that the volume of the metallic stone will be W, that is mass, divided by density. This much meter cube should be W by P, W by rho meter cube should be the volume of the metallic stone. Okay. Also, it is given that when the metallic stone is dropped, is immersed completely in a measuring cylinder, the reading increases by P ml. So, from the concept of measuring volume of a solid using a measuring cylinder, we can say that the increase in reading in a measuring cylinder that is equal to the volume of the solid body immersed. So we must have P ml, P ml, this much volume, this much PML is the volume by which the reading was increased. That is, this should be equal to the volume of the metallic stone. Now, volume of the metallic stone we have W by rho is in meter cube. This must be equal to PML, but first we have to convert the PML into meter cube. So this will be equal to 1 ml is 1 ml milliliter. 1 milliliter is equal to 1 centimeter cube, and 1 centimeter cube is equal to 1 multiplied by 10 to the power minus 6 meter cube. So this will be equal to PML will be equal to P multiplied by 10 to the power minus 6 meter cube. So now we can say that W by rho should be equal to P P multiplied by 10 to the power minus 6. This implies P is equal to W by rho multiplied by 10 to the power minus 6, which is equal to W by rho multiplied by 10 to the power 6. W by rho multiplied by 10 to the power 6 should be the value of P, and I am not having any choice. Let me see if I have done correctly or not. The weight is given as W kgf, so the mass is W kilogram. Okay, the density is given as rho kilogram per meter cube. Okay, so the volume will be W by rho meter cube. W by rho meter cube. Okay, this should be equal to the increase in reading in the measuring cylinder, which is PML. Now PML is equal to P multiplied by 10 to the power minus 6 meter cube. PML is equal to P centimeter cube. Now 1 centimeter cube is equal to 10 to the power minus 6 meter cube. So PML should be equal to P multiplied by 10 to the power minus 6 meter cube. So W by rho should be equal to P multiplied by 10 to the power minus 6, which means that capital P is equal to W by rho multiplied by 10 to the power 6. I don't know. So this is my answer is coming as W by rho multiplied by 10 to the power 6. I might have incorrectly given the choices, so my answer is not matching with any of the choices. Anyway, so this is the correct answer. The value of capital P should be W by rho multiplied by 10 to the power 6. Okay, let's see the next problem. Question number 4. A measuring cylinder of capacity capital ml is filled with water at a level of VML. So the capacity of the measuring cylinder, the capacity, so we are having this kind of cylinder. So this, the highest mark graduation is given as VML. Okay. Is initially filled with water at a level of VML. So we have water. Let's say this is the water initially. This reading is VML. ml means milliliter, which is 1 ml means 1 centimeter cube. Okay. What should be minimum density in gram per centimeter cube of a body of mass capital M gram, whose volume can be determined by completely immersing it in this cylinder? What should be minimum density of a body of mass M gram, whose volume can be determined by completely immersing it in this cylinder? The mass is given of the body of the mass of the body is given as M gram. Okay. Now, minimum density. We know that density of a substance or body is mass by volume. Now, if the density is minimum, so from here we can say that minimum density, if the value of density is minimum, this will imply that the volume has to be, mass is fixed, mass will not change. This implies that the we must have maximum V. From this relation, that rho is equal to, or density is equal to mass by volume, if the density for a given mass, if the density has to be minimum, then of course the volume has to be maximum, because volume is in the denominator. So now we have to find what is the maximum volume that volume of a body that this measuring cylinder can measure. We know that when a body is immersed, in this measuring cylinder, the level of the reading will rise. The reading will increase due to the by an amount which is equal to the volume of the body immersed. Now, since the initial level of the water, the volume of the water is VML, clearly we can see that the maximum possible, the maximum increase, since the capacity of the measuring cylinder is Vm, the maximum increase in reading possible in this measuring cylinder where the capacity is Vm and the level of the initial and the level or the volume of the water initially is the VML, we can say that the maximum increase in reading can be Vm minus V, this much ml. So clearly this measuring cylinder can measure the maximum volume, that the maximum volume of a body that this measuring cylinder can measure is Vm minus V. So this implies maximum volume of the body, maximum volume of the body can be Vm minus V, this much ml. Okay, so this implies minimum density. If I denote the minimum density to be rho min, will be equal to the mass. The mass is fixed, it is given m divided by Vm minus V. This much gram per centimeter cube should be the minimum density of the body having a mass of m gram, whose volume can be measured using this measuring cylinder, that is a measuring cylinder having a capacity of Vm ml and where it is initially filled with water at a level V ml. So the correct choice is D. D is the correct choice. Okay, let's see the last problem. Question number 5. During determining the volume of two irregular solids A and B using an Eureka can, it was observed that the measuring cylinder reading for B was 1/4 that of A. If B has a mass half that of A, then which of the following choices is correct? Where it is given that rho A is the density of A and rho B is the density of B. Okay, so we know that in a Eureka can, when a Eureka can is used to find determine the volume of a body. So we immerse a solid body in a Eureka can. The Eureka can is the setup is that we have a Eureka can. It is something like this. This is the spout. This is the spout. And the height at which the spout is, the capacity of this Eureka can contain water or any liquid. The maximum volume when it is completely filled, when this Eureka can is completely filled, then the level of the liquid inside it or water will be at a level of the spout. So any excess liquid, if you add any extra excess liquid or water, it will come out or splash out from the spout. So the idea is that when you immerse a body, when you gently immerse a body inside this Eureka can, which is completely filled with water, then definitely some water will be displaced. Now since the Eureka can is already filled with water, the displaced water will come out from the spout, and that displaced water is collected in a measuring cylinder which is kept just below the spout. And from the reading of the measuring cylinder, that reading will be nothing but the volume of the water that was displaced from the spout, and which is equal to the volume of the body. So this is the concept of Eureka can. So in this problem, it is given that when during the determination of volume of the two irregular solids A and B, for A, let's say we are determining the, so this is A, let's say this is A, body A. So now let's say the reading of the measuring cylinder is, let's say this is VML. No unit is mentioned in this problem, so we did not mention whether it is ml or usually a measuring cylinder, the graduations are done in ml, but let's say it does not matter. I mean, it will not make any difference if I consider the reading of the measuring cylinder to be VML while we are determining the solid of while we are determining the volume of the irregular body A. Okay. Let's say the mass of the body A is capital M A, and also we are given the density of the body A is rho A. Now similarly, while determining the volume of body B, the reading of the measuring cylinder is given to be. It is saying that during determining the volume of two irregular solids A and B using an Eureka can, it was observed that the measuring cylinder reading for B was 1/4 that of A. So clearly the reading for B will be V by 4 this much ml. And let's say the mass of the body B mb, and the density is given as rho B. Okay. So now what is the question? Okay, so if B has a mass half, if B has a mass half that of A, so which means that MB is equal to MA by 2. Okay. Then which of the following choices is correct? Rho A is equal to rho B, rho A is less than rho B. Okay. So we have to find how rho A and rho B are related to each other. Okay. Okay. So for the case of body A, we can say that V, the reading in the measuring cylinder, which is VML, V, the volume of the body, should be equal to mass of the body, which we have assumed to be MA, divided by the density rho A. Okay. Similarly, for the body B, we can say V by 4 should be, which is the volume of the body B, should be equal to mass divided by density rho B. Okay. Now, okay. Now, what is MB? MB is MA by 2. So, MB by rho B becomes MA by twice rho B. Okay. So, V by 4 is MA by twice rho B, and B is MA by rho A. This implies from the determination of the volume of body A, we got V volume is MA by rho A. Now, from the body B, in the case of body B, we can say that V is equal to, by doing cross multiplication, we can say that V is equal to 4 times MA by twice rho B, which is equal to twice MA by rho B. So now we can equate. So we got the value of V. We got V is equal to MA by rho A. Also we got V is equal to twice MA by rho B. So we can equate the two values of V, values of V, and we can say that MA by rho A should be equal to twice MA by rho B. From here we can cancel out MA from both sides, since MA is a non-zero or MA is a positive quantity. So this implies we get rho B is equal to twice rho A. Rho B is equal to twice rho A. Okay. So clearly the choice D is incorrect, because it says rho A is equal to 3 times rho B. So from here we can clearly say that what we can say that rho A is definitely, so rho A is equal to rho B by 2. So this implies rho A is definitely less than rho B. So rho A is less than rho B. So choice B is the correct choice. So with this, it comes to an end in solving another set 2 of 5 multiple choice questions based on determination of density of solids. Once again, if this video was beneficial, then please like it, share it with your friends, And if you want to support me, then please subscribe to my channel. And in that case, please do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will explain, I will discuss the key concepts and formulas about how do we measure the density of liquids using a density bottle. So please stay tuned for that video. Thanks for watching, and until the next video, take care and bye.